So when we took our dive into circles, we started with the idea of thinking about how circles and ellipses are related. And I said, you guys don't know what ellipses are yet. Well, now you kind of do. And so now my question circles back to, when are ellipses circles? Yep, like when is a door not a door, when it's ajar? Kind of like that, not even close. But when are ellipses circles? What does it take in the equation for an ellipse to actually secretly be a circle? So we are going to do a little bit of a dive into ellipses, and we're going to look at a lot of the same things that we've looked at in the past and kind of piecing together and whatnot. But now we kind of have to focus on, just like we did with parabolas, whether our ellipse is horizontal or whether it's vertical. But we'll get there. You guys will get this. So because we want to keep tradition alive, let's define what ellipses are first. Ellipses, in all of their glory, are the set of all points. We should just abbreviate that SOAP. We're not going to, but it kind of would be cool. Okay, whose distances. So this is going to be a little bit different because we're going to start talking about kind of pieces together, but whose distances, we're talking about more than one now, from two fixed points about to give those a name. Those two fixed points are called foci. And those distances have a constant sum. So we're going to draw a bunch of points, but that's what we're going to kind of keep in the back of our mind. I want to give you some key pieces of ellipses, but before I do that, I want to make sure that we kind of all know how this fits together. And so I'm going to lay out some of our vocab on an ellipse, and then as we get into the equations, we'll kind of hammer more vertical versus horizontal, but right now I'm just going to talk about a horizontal ellipse. So let's see. Because that might have been the greatest ellipse I've ever drawn. I feel like I should frame it. And maybe I will, we'll see. Anyway, in this ellipse has a center. Then this ellipse has two axes, right? It has one that's longer. That is called the major axis. And at the end points of our major axis are the vertices. It also has a minor axis. And at the end points of the minor axis are the co-vertices. Then we also have our foci. So there's 2 points on our major axis. That are our foci. Individually, they're each called a focus. Plural is foci, not foci, although at least 3 of you will want to say foci, and I wish I was with you because that would make my heart so happy to hear you say foci, but we're going to call them foci because that is what their name is. Now, before we get too much further, just to lay out a couple more pieces of information, the distance from the center to the vertex is A, and center to a co-vertex is B. So we're going to use the letters A and B a lot, and it's more just to make sure we all are on the same page with what each one means, right? In an ellipse, A is always the bigger number. So two equations that we're going to look at. The first one starts off like this. And I know some of you are like, Vista, that's a circle, I remember. Well, good, I'm proud of you. But now I'm going to add denominators. And in those denominators, I'm going to give them A's and B's. And then I'm going to write the other one really quickly. I might be going back and doing some whiteout to give us a little bit more room. But we're going to do our best. If I switch and put A under the Y, that changes it a little bit. So two equations, each with their own wrinkles and own information. Let's kind of talk about what each one tells us, and then we'll go from there. If the bigger number is under the X, that's when we are looking at a horizontal ellipse. And if the bigger number is under the Y, that's when we're looking at a vertical ellipse. And so that's just kind of the difference between the two. Okay, so now, let's get this kind of slid up so we have a little more room to write. We are going to do a little bit of a dive into what each one of these equations tells us. And so the first thing we're going to look at is, let's see, so we're going to talk about the major axis. We're going to talk about something called the semi-major axis. We're going to talk about the semi-minor axis. That is such a funny word, semi-minor, but all it means is half of the minor axis. So it'll make more sense here in a second. We're going to talk about where our vertices live. We're going to talk about where our co-vertices live. I didn't write down the center, but hopefully you can kind of start to see the pattern of the centers at H and K. If not, we can totally dive back into that a little bit. Then I'm going to skip about 1, 2, 3 lines because there's something I got to show you real quick. Super cool, fun stuff. And then we're going to finish up with talking about our foci. I love all of you who are like, Vista, it says folky. I miss you. So we're talking about the foci to kind of finish this up. So let's look at our horizontal ellipse first. So in this horizontal ellipse, the major axis runs parallel to the x-axis. The semi-major axis has a length of A, right? That's this A that we kind of talked about up at the top. Let's go back up there. That would be the semi-major axis. If we wanted to talk about the major axis altogether, we would say that the major axis has a length of 2A. That is different from the denominator. The denominator is A squared. When we talk about the axis, we have to take the square root and then use that. The semi-minor axis has a length of B. Now, the vertices, this is a horizontal ellipse, and so the vertices move out from the center to the left and to the right. So we're going to take our ordered pair from the center, and then we are going to add A and subtract A to get to where our vertices are. Our co-vertices, they move up and down, so we're going to add and subtract B. Okay? I'm going to pause. Let's talk about the up and down one, and then we'll talk about foci all together at the end. So up and down, that would be parallel to the y-axis, still has a length of 2A. Okay? Still has a length of 2A. And what I mean by that is A is always the biggest number. So if this is an up and down one, A is under Y, A is bigger than B. And when we look at it, we just have to be mindful of which one's bigger and how is that going to determine our shape, okay? Because for a vertical one, now we are going to move up and down a distance of A. And our co-vertices are going to move left and right by the distance of A. Okay, so now there's something a little bit different here. We have to talk about our foci because that's a key piece of information here. And we are going to talk about our foci using something that feels a lot like the Pythagorean theorem. A squared. A squared, remember A squared is just right from the denominator, equals B squared plus C squared. Okay? Kind of looks familiar. Some of you are like, this is a Pythagorean theorem, I recognize it. I'm going to give it to you one other way because a lot of times we're going to need to know what C is. C squared equals A squared minus B squared. That's going to come in handy for us. Kind of formalize some of that language and get some of that figured out. If you're kind of confused, all I did from the first equation to the second equation is just move B squared over from being on C squared side to the other side. Because knowing what C is going to be kind of a helpful piece of information. So when we look at this, and it feels kind of like Pythagorean theorem, that's super cool. Just know that we are going to use that equation to find what C is so that we can determine where our foci are. That's kind of a key piece of what we're looking at. And so we are going to use that equation. I almost like the second one a little bit better, not for any particular reason, but because it's nice to just be able to subtract and not actually have to think about a ton of solving with anything. And so feel free to use whatever one works best for you, but kind of go with that, or go with whatever one you feel most comfortable. Okay, now, once we know what C is, then what we're gonna do is we're gonna write the ordered pairs of our foci. So the first thing we're gonna do is the horizontal one. C for a ellipse just tells us that how far we need to move. So if we're moving horizontally, we're just gonna do plus or minus C, comma K. And then over here, we're gonna do the same thing, but we're gonna do our plus or minus C onto K. So lots of good things here. The final piece of information I'm gonna give you is just a formula that's gonna kind of come in handy a little bit. It's gonna come up every now and then. We can talk about the eccentricity of an ellipse. And it's basically a ratio that tells us how squished our ellipse is. I'm not too worried about the definition of it, but as we do it, we're gonna use C over A to calculate it. So because C is smaller than A, this should be a fraction of less than 1. If it's exactly equal to 1, that's super cool, that's a circle. But lots of stuff going on with ellipses. I think you're gonna get it all figured out. Be in touch if you can't. I know you've got this. Do great things.